Welcome to the deep dive. You know, it really feels like we're in this remarkable moment for AI.
Absolutely. Things are moving so fast.
Right. Research, deployment, it's accelerating like crazy. And the projections, well, they suggest that over the next, say, 5 years, these aren't just cool concepts anymore.
No, they're becoming real infrastructure,
Yeah.
foundational stuff.
Exactly. We're talking about technologies that are really poised to reshape industries, public policy, even your everyday life. Okay, let's unpack this. In this deep dive, we're diving into something truly fascinating that's right at the cutting edge. Self-Supervised Robotics. SSR. Basically, robots that learn by watching.
And what's truly fascinating here is how fundamentally this changes the paradigm of robotic intelligence. It really does.
It shifts everything.
Yeah. So our mission today really is to explore what self-supervised robotics actually is, how it works, the nuts and bolts,
Okay.
and also its expected timeline, what's driving it, and importantly, the big challenges, societal, technical, that come with it.
Right.
At its core, we're looking at how robots are getting this ability to learn independently. Understanding that as well, it's key to grasping a big piece of our near future.
That sets it up perfectly. So let's jump straight into that core idea. What exactly is self-supervised robotics? If we break it down, SSR means a robot is independently gathering data.
Right. On its own.
Not from labeled examples humans feed it, but
Yeah.
through its own interactions. Bumping into things, picking things up.
Exactly. Its own experience with the environment.
And here's the kicker, the profound shift. It uses this data it generated to learn new actions, predict results, all without needing human labels or someone correcting every mistake.
Precisely. No hand-holding in that sense.
Think about that. A robot just exploring, interacting, and figuring out what works and what doesn't from watching itself. The implications of that kind of independent learning feel, well, huge, immense, aren't they?
They absolutely are. And, to elaborate on how they do this, the research really points to them focusing on fundamental physical things.
Like what?
Activities like grasping objects, manipulating them carefully, understanding their surroundings through perception.
Basic physical skills.
Kind of, yeah. But by doing these things over and over in different ways, the robot builds up its own experience base. It's like it's running little experiments all the time.
Ah, okay. Experimenting.
And the real benefit here is that this lets robots genuinely get better, especially in those messy, unpredictable real-world places where older robots, the rigidly programmed ones, just struggle.
Right, because the real world isn't neat and tidy.
Not at all. So this approach improves generalization, meaning the robot can take what it learned and apply it to new situations it hasn't explicitly seen.
Okay, makes sense.
And sample efficiency, which just means it needs way less training data compared to older methods to get good at something.
Less data needed, that's a big plus.
Yes. Essentially, it makes its own data, its own guidance. It adapts more efficiently than being spoon-fed instructions. If we connect this to the bigger picture, it's about robots generating their own training wheels, if you will.
I like that, training wheels.
Yeah, and constantly improving them without needing a human to step in. It's like, imagine a kid learning to ride a bike, but then instantly sharing that balance skill with every other kid getting on a bike for the first time.
Wow. Oh, okay.
And the field uses specific methods for this, like predictive coding and contrastive learning.
Okay. Training wheels, predictive coding, contrastive learning. Predictive coding, that sounds intuitive enough, guessing what happens next. But contrastive learning, that sounds a bit more technical. Can you maybe unpack that one a little? Here's where it gets really interesting.
Sure, yeah. So predictive coding, just quickly, is basically what you said. Learning to anticipate what's coming next. Sensory inputs or states based on what's happening now. The robot makes a prediction, sees what actually happens, and updates its understanding.
Okay, prediction and correction.
Right. Contrastive learning, though, it's a bit different. It's a machine learning trick that teaches a model to tell similar things from dissimilar things by comparing them.
Comparing, how does that work for a robot?
Well, imagine the robot tries to grasp something, like an apple. It takes a picture, maybe from a slightly different angle. Those views are similar.
Right, same grasp.
Then it compares those to pictures of, say, a different object entirely, or maybe a time it failed to grasp the apple. Those are dissimilar.
Oh, okay. Success versus failure, or apple versus orange.
Exactly. And by learning to sort of mentally pull the similar examples together and push the dissimilar ones apart, it figures out what a good grass looks like or what an apple looks like without anyone ever telling it that's an apple or that grass failed.
So it learns the categories by comparison, not by labels.
You got it. It's a really powerful way to learn relationships, all self-supervised. And crucially, the sources highlight 2 key abilities robots need to develop through this. First, action effect prediction.
Action effect, cause effect.
Pretty much.
Right.
Learning that if I do this action, that is the likely result in the environment. If I push here, the box moves there. Learning those physical rules.
Makes sense. And the second?
The second is intention prediction. This is fascinating. It's about figuring out if a human nearby is likely to interact with it.
Not just waiting for a command.
No, it's more subtle. Looking at cues, where's the human looking, how are they moving, their posture, and comparing that to its past experiences to anticipate, okay, this person might need something from me or might walk this way.
Wow.
So those 2 together, predicting physical outcomes and human intent, give the robot this amazing foresight and ability to react smoothly. It makes them feel much more like collaborators working with us, not just tools.
That foresight really does change the game. They're not just passive machines then. So, okay, if they can learn like this, what are the immediate, real-world benefits we're seeing? Why does this matter right now?
Yeah, so why does this matter? The source material suggests this is a huge deal. The immediate value, maybe the most striking one, is how quickly robots can learn new, complex tasks.
How quickly?
We're talking about learning from just a few minutes of watching a video rather than someone spending weeks or months writing detailed code for every single movement.
Minutes versus months.
Potentially, yeah. Think about the programming effort for current industrial robots. It's huge, specialized work. SSR could just slash that. It unlocks really flexible automation for logistics, manufacturing, even maybe robots in the home.
Okay, and the timeline for this becoming widespread?
Well, the projections are pretty aggressive, actually. Right now, SSR is mostly in the industrial pilot stage. Companies testing it out, refining it.
Okay, testing phase.
But the expectation is for it to hit the mass market somewhere between 2028 and 2029.
That's really soon. Well, less than 5 years, potentially.
It shows how fast this could potentially change things across a lot of sectors.
Okay, let's zero in on manufacturing. How could this really affect manufacturing? You mentioned retooling.
Right. So the sources specifically call this out. SSR could radically reduce the time it takes to retool a production line.
Which is usually a massive bottleneck, right?
Huge. Months of work, complex reprogramming, calibration. If you want to make a new product or change an existing one significantly.
And SSR changes that how?
The potential is to shrink that retooling time from months down to days.
Months to days.
Yeah.
Just let that sink in.
Yeah. And think about the economic implications. It's not just faster, it makes businesses incredibly agile.
They can react instantly.
Almost. Adapt to market shifts, new designs, supply chain hiccups, nearly in real time. Less money tied up in rigid setups, faster from idea to customer. It could unleash a wave of innovation.
Days instead of months. That's staggering for manufacturing. But like you hinted, it's not just factories, is it? What about closer to home? Home and service industries.
Yeah, this is where it could get really personal for you, for everyone listening. The same idea applies to personal robots, service robots.
Like a robot helper at home or in a hotel.
Exactly. Instead of needing complex software updates for every new task, imagine it learning a new chore just by watching a quick video.
You mean I show it a video of how I like the table set? And it learns.
That's the vision. Or it watches you doing something, tidying a shelf maybe, and figures out how to do it, adapting to your specific way, your home layout.
So they adapt to us, not the other way around.
Precisely. That makes them far more useful, more integrated into our actual lives, not just these generic machines.
That is a profound shift.
Yeah.
Moving from static tools to dynamic collaborators.
Okay, but for this to really scale up, there's the question of sharing knowledge. If one robot learns a skill, can others get it easily? So what does this all mean for scalability?
That's a really important point. And the answer seems to be a clear yes.
Okay.
Once one robot, say, a specific model, learns a new skill through this self-supervision, that knowledge isn't stuck in that one unit.
It can be shared.
Yeah, the idea is that learned behavior can be passed on, sent out to other robots of the same model that haven't even been deployed yet, or update existing ones. It becomes like a baseline skill upgrade for the whole fleet.
So you're creating this constantly improving collective intelligence for that robot model.
Exactly. It's a compounding effect. Every robot benefits from the experience of all the others. One robot learns something tricky in the real world, that insight potentially updates thousands, millions of others. That's a paradigm shift in how technology improves. Machine speed, collective learning.
It really is a new model for how these systems could evolve.
Okay, the potential is clearly massive. Collective intelligence, learning from video. But let's be real. Of course, with great potential comes great challenges. This won't be a perfectly smooth rollout, will it? What are the big roadblocks?
You're absolutely right. It's definitely not straightforward. There are some major hurdles. First one, maybe one of the trickiest, is safety certification.
Safety. Always critical with robots.
Especially with robots that are learning on the fly, right? They're adapting, making decisions based on their evolving understanding. What happens if they make an unexpected choice that impacts safety?
How do you certify something that's constantly changing its own behavior?
That's the million-dollar question. This raises an important question. How do we certify something that is continually learning and adapting? It's not like testing a fixed machine with predictable outputs. It's validating a process of learning.
That sounds like a regulatory nightmare.
It's a huge challenge. Ideally, we'd need global standards for this, but getting everyone to agree, well, that's likely to take time. Safety has to be paramount, but figuring out how to ensure it for learning systems is tough.
And safety isn't the only hurdle involving rules and regulations, right? What about legal liability?
Another big one, yeah. If, or maybe when, a learning robot makes a mistake that causes damage or harm, who's responsible?
Is it the manufacturer? The programmer who set up the initial learning, the owner using it, the robot itself, eventually?
Exactly, all those questions. And different countries have totally different legal systems. This lack of clarity could really slow down how quickly these robots spread globally until we figure out liability. It's genuinely new legal ground.
Okay, safety certification, legal liability. What about the tech itself? Are there technical roadblocks too?
Oh, definitely. A major one is the simulation to real-world gap.
Sim to real. You mean training into simulation versus reality?
Precisely. Simulations are amazing for training robots quickly and safely. You can run millions of trials overnight. But the real world is messy, unpredictable. Simulations are clean. Physics are often simplified. The real world has weird friction, changing light, dust, clutter, people doing unexpected things.
All the stuff that's hard to model perfectly.
Exactly. That long tail of rare events. So getting a robot that performs brilliantly in a simulation to be just as robust and reliable out here in the physical world, that's still a significant technical challenge.
Yeah.
Bridging that gap is crucial.
It sounds like there's still a way to go on that front. Okay, this has been incredibly insightful. Let's maybe do a quick recap on SSR. The core idea, machines learning by watching the results of their own actions, not needing constant human labels or corrections.
Right. Intrinsic independent learning.
And the benefits we talked about. Learning new skills much faster, always getting better using cheap self-made data, being more ready for surprises, and just generally more adaptable.
Absolutely. And ultimately what this means for you, the listener, it points towards a future with robots that are much smarter, more flexible partners.
Partners, not just tools.
Yeah. Self-supervision makes them cheaper to train, faster learners, and way more versatile and dependable when they're working alongside us. In factories, yes, but also potentially in service roles, maybe even at home. They become collaborators that can evolve.
Thank you so much for joining us on this deep dive into self-supervised robotics. It's clearly a field moving incredibly fast, and yeah, it really looks set to redefine a lot of things in the next few years.
It's exciting and a bit daunting.
Definitely. So as we wrap up, here's something to think about. If robots can learn complex new skills just by watching a video or through their own trial and error, and then instantly share that skill with countless others, what completely new, maybe unforeseen tasks might they master in the next decade? Things we can't even properly imagine right now.
That's a fascinating question to ponder.
Keep an eye on these developments. They're changing the world faster than we might think.
Absolutely. There's always more to learn, and this field is just beginning to unfold its full potential. We hope you stay curious and keep thinking critically about how all this will shape our world. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.